Hi. Now we are entering the fourth questions in law of conservation of energy. The only thing about these questions is it involves the energy loss due to friction. Okay. Let us read the question together. Refer to the figure above. Object B is released from rest. Okay. Release the block B. When it falls 0.5 meter, its speed is 2 meter per second. That means it falls losing the gravitational potential energy but gaining the kinetic energy. Okay. Uh, determine the work done by the friction force which acts on A. Yeah, apparently block A is placed on a rough plane, so it has energy loss due to friction. Okay. So we apply the law of conservation of energy. The initial total energy equal to the this is actually the final sorry so this is the final total energy. So some part of the energy has converted to the uh, heat or the energy loss. Okay, some part of the initial energy has converted to the heat energy, which is the work done due to friction. Okay, and it becomes the energy loss, yeah, from the system. Now, okay, let's identify the initial condition, yeah, the energy that exists in the initial condition and also the energy exists in the final condition. So what energy exists in the initial conditions? Okay, so this is the initial and this is the final. Okay, so initially, yeah, at the it has certain height. So we know that it has the potential energy. The block B, it has certain gravitational potential energy. So it has potential energy. This is for block B. And after it falls, okay, some of the energy has lost. Okay, energy lost as heat. This energy is lost. And the block A has gained some kinetic energy. So it has the kinetic energy for block A. And also the block B also gains some kinetic energy, final kinetic energy for block B. And that's it. Okay, we assume the block B now at this level after 0.5 meter, it has no potential energy. We assume this level is zero gravitational potential energy. Okay, above 0.5 meter, it has potential energy mg delta h. Delta h is the difference in the height, 0.5 meter. So initially block B has this mg delta h initial potential energy. Okay, so you see, initial condition, the block B has the gravitational potential energy mg delta h. After the block B falls, the block A gains kinetic energy, block B gains kinetic energy, and there are some energy loss as heat. Okay, so that's it. Let's try out the questions. So initially it has no kinetic energy, but it has the potential energy. Initial potential energy for block B, and this is B. And then finally, it has zero potential energy, but it has a kinetic energy, the final kinetic energy for block A, and also the final kinetic energy for block B, and also some part of the initial energy has turned to the work done against friction. So this is the energy loss, yeah, or we can say the energy as heat energy, loss as heat. Okay, so then apply the formula. So this is mg delta H initially has gravitational potential energy. This is mass of B. And then finally, we have mass kinetic energy for A, mass of A, V square plus half mv square, but this is mass B. And this is the energy of heat which we want to find. Okay, both blocks have the same velocity because they fall together tied to a string. So both blocks have the same velocity, VV, same velocity. So they have the same velocity, only mass different. Okay, so let us substitute the information. We have a 1 kilogram, 1 kilogram and 2 kilogram. So block B is 2 kilogram. So let's substitute. 2 kilogram, 9.81. The delta H is 0.5 meter. 0.5 meter. 0.5. You see, 0.5 meter. And let's continue. So half, the mass of A is 1 kilogram. Velocity is 2 meter per second. Yeah, over here, meter per second. Okay, plus half, mass of B is 2 kilogram. Velocity is 2 meter per second plus heat of the energy of the heat. Okay, yes, so we got the energy of heat, the energy loss, 3.81 joule. Right. So work done against friction, so we can say work done against friction is equal to the negative 3.81 joule. We should put a negative sign because energy loss. Okay, because energy loss, so we need to put a negative sign for this work done against friction. So that's it. Okay, for these questions. Hope you enjoy the videos. So stay tuned for the upcoming videos. Bye.